Hey you guys, well we're here. This is your first remote learning video that I'm doing. I'm going to sort of recap homework 38, what we went over, because this is super duper important. Okay, we started with definition of logarithms. Now that is one of the most important things you can understand regarding the logarithms. If you don't understand the meaning of a logarithm, how to convert a logarithm from logarithmic form to exponential form, that is where people generally have trouble with all of this. So it's really important that you understand how to convert from one form to another. So I'm going to show you basically how to do that, first of all. And you probably already saw this in videos. Hopefully you already understood it, because I did give you some videos to watch regarding this topic. But here's how it goes. First of all, we're doing definition of logarithms. And the first thing I want you guys to understand about this is, okay, 9, 5 plus 4, 3 times 3. Those are all three ways of saying the same thing. They're all three ways of just saying 9. You can say 9 as 9. You can say 9 as 5 plus 4. You can say 9 as 3 times 3. They all mean the same thing. You could substitute one for the other because they all mean the same thing. So they all look different, but they mean the same thing. Okay, now I'm going to translate that over to logarithms. Now we're going to start looking at stuff that you guys are super familiar with already. Everybody should know this right here. 2 to the third power equals 8. If you don't know that, there is a problem, because you should know that 2 to the third power equals 8. That is a fact, okay? A fact that everybody should know, okay? Now, I'm going to write 2 to the third equals 8 in a different way that you probably aren't familiar with. But all it says is 2 to the third power equals 8. It's like this. Log base 2 of 8 equals 3. Notice the base goes right here, the thing you're raising to the power right here. The answer goes right here, and the actual power that you're raising this guy to get this number goes right here. The exponent goes right here. This is called logarithmic form. This is called exponential form. So I just converted from exponential into logarithmic form. You know what this thing says? 2 to the third power equals 8. That's all this says, okay? It's just a different way of writing it. So just understand that. It's kind of different, kind of weird, but it's really that easy. So let's check this one out. 7 squared equals 49. Well, the base is 7, so it's going to be log base 7 of the answer, 49, equals the exponent 2. I just converted from exponential form into logarithmic form. It's that easy. Notice I'm not solving anything. I'm not finding anything. I'm not saying, is this true? I'm accepting this is true, and I'm just writing it in a different way. Okay, 6 to the 0 power equals 1 is a true statement. Anything to the 0 power is 1, except 0 to the 0 is undefined. But any other number to the 0 power is 1. So this is a true statement. How would I say it in logarithmic form? I'd say log base, whatever is being raised to the power, in this case 6, of the answer equals the exponent, 0. So log base 6 of 1 is 0. It really is that easy. Okay, now, hopefully you understand that, okay? Oh, I thought we were jumping to logs. We're still logarithmic to exponential. Let's do one more exponential, okay? So it's going to be log base 9 of 27 equals 3/2, right? I'm not asking, is 9 to the 3/2 power equal 27? I'm telling you, this is a fact. Let's just write it in a different way. So log base 9 of 27 equals 3/2. This still says 9 to the 3/2 equals 27. Okay, over here. Now I've got them starting in logarithmic form. I want to convert into exponential form. So that's just going to be the base, 8, raised to the exponent over on this side, negative 2/3 power equals 1/4. 8 to the negative 2/3 power is 1/4, and that is a true statement. Okay, that is from logarithmic into exponential. Okay, over here, log base 5 of 5 root 5 equals 3/2. The base is 5, so that's what you raise to the power, right? Raised to the 3/2 power, the exponent's over here, equals this thing right here. I just converted from logarithmic into exponential form. It really is that easy, and I don't know how to say it any clearer than that. That's how you convert. It's just converting from one form into the other. Now, sometimes you'll have to convert from exponential into logarithmic. Sometimes you'll have to convert from logarithmic into exponential. You have to go both directions, so you need to know how to do it both times. Also, more often than not, when you're doing logarithms, you're gonna have to do this within a problem. Most logarithm problems involve converting from one form into the other in order to solve them. So it's very important you know how to do this. Okay, so if you or somebody you know is having trouble on logarithms, very likely they don't understand this thing. If you don't understand how to convert from one form into another, you're going to be thoroughly confused on logarithms. So if you or if any friend of yours is having trouble with logarithms, this is what I do. Whenever a student's having trouble with logarithms, first thing I ask them is this. I put 2 to the third equals 8, and I say convert that into logarithmic form. And if they say, I'll say, there's your problem right there. You cannot convert that straight up into logarithmic form. You are going to have serious trouble with logarithms. You won't be able to do it. If I say, what's 2 to the third equals 8, and you say, log base 2 of 8 equals 3, then I'm going to say, okay, great. You know how to convert that. Now that's not the problem, and then we could go on to try and help you with whatever else you're having trouble with. But the first thing you've got to understand is how to convert from one form into another. It's super duper important. Okay? In fact, it is so important that I actually wrote a song about it. Okay, so I'll show you my song right here. Oops. Actually, yeah. Okay, here's the song. When working with logarithms, when in doubt, what do you shout? Convert or eat dirt. See, that's how it works. It sounds better when it's a whole class of people saying it, but that's it. When in doubt, what do you shout? See, it rhymes. Convert or eat dirt. Now, the idea with this is I'm convert or eat dirt. Let's see, I can convert or I can eat dirt. So if you are say a dirt eater, and that appeals to you, I would not recommend it. The only reason I have it in that saying is because it rhymes, okay? I'm not recommending that you eat dirt. In fact, I'm recommending that you convert. When in doubt, what do you shout? If you don't know what to do, if you're working out a logarithm problem and you don't know what to do, try converting. It's usually the right thing to do. Never eat dirt. Eat dirt's never the right choice, okay? It's always convert. Now, you may try to convert and it doesn't help, then no harm done, right? But if more often than not, if you convert, that's going to be a good step. So if you reach a point where you don't know what to do, try converting. It's usually the right thing. Okay. Now I want to go back and do one problem I forgot to do before I showed you that, and that's not this problem. Whoa, I went the wrong direction. Okay, right there. Log base 5 of 125. Notice now this is a little different than what I had. Here I was having the whole statement, right, and converting it from logarithmic into exponential. Here's what I'm saying here. Notice what this means. Log base 5 of 125 is what? So you know what I'm going to do? I'm going to think and say, wait a minute, okay, here's what this means. It means 5 raised to what power gives me 125 for an answer. 5 to what power is 125? Well, I clearly know that, and you should know that. 3, boom. So sometimes you could just look at a logarithm like that and just see what the answer is, right? What power do you have to raise this guy to get this for an answer? No, I'm sorry. What power do you have to raise this guy to get this for an answer? Turns out to be 3. So log base 5 of 125 is 3 because this is the power you have to raise this guy to get this answer. Okay, now I'm going to show you a little more difficult one. So here we go. This one right here. Log base 2 of 8 root 2. In fact, let me erase these things real quick. And then we can start off with a nice clean board. So here's what we're going to do. Okay. So we've got log base 2 of 8 root 2. Now what does that mean? That means what power do you have to raise 2 to get 8 root 2 for an answer? That's the question. 2 to what power gives you 8 root 2 for an answer, okay? So I'm going to show you how we solve. So say you don't know what to do. And let's see what happens. Say you don't know what to do. Well, here's what the first thing I do. Give it a name, right here, up here. Look, log base 2 of 8 root 2. You don't know what to do. What is that going to be? I don't know. Give it a name. Let's call it x. I usually call it an x when I give it a name. You could call it y. You could call it whatever you want. I'm calling it x, okay? So now we have log base 2 of 8 root 2 equals x, right? I gave it a name. Now what do I do? Well, I would say, I don't know about you guys, would you say that at this point that you're somewhat in doubt as to what to do? Well, I've got an idea. If you're in doubt, what should you shout? Let's see, convert or eat dirt? I'm going to convert. So, convert. So what's the base? 2 raised to what power? X equals 8 root 2. This base to this power equals this. I just converted. That's all I did. Convert. Now, how do you solve when the variable's in the exponent? Remember, we talked about this before. We did this a couple of assignments ago. You try to make them powers of the same base. That's the key. So here, this is already a power of 2. 8 and square root 2 are both powers of 2. You can make 8 is 2 to the 3rd power times root 2 is 2 to the 1/2 power. Square root is 1/2 power. So I just made it like that. Now, 2 to this power times 2 to this power is add the exponents. 2 to the 3 plus 1/2. That's going to be 2 to the x is 2 to the 6/2 plus 1/2 is 7/2. 2 to the x is 2 to the 7/2 power. Now, this is the nice part about all this. If you can make these powers of the same base, look, they're both base 2, right? The overall quantities are equal to each other. If the bases are equal and the overall quantities are equal, then the powers have to be equal. So the beauty part about this is you can throw away the bases and just set the powers equal to each other. X equals 7/2. And guess what? We called it x. When we find x, we found the answer. It's going to be 7/2. That's how that problem works. Okay? So, let's go to the next one now. Okay, how about this one? Log base x of 81 equals 4. Okay? What are we going to do to solve for x? Well, let's see if you can guess. I'm going to do one of two things. I'm either going to convert or I'm going to eat dirt. I'm going to convert. So here we go. It's going to be x to the 4th power equals 81. Okay. Now you might say, well, what do I have to raise to the 4th power to get 81? Well, I could see it's 3. I don't know if you can see it's 3 right now. But wait a minute, there's one thing we got to think about. Okay. The other way we could do it is, hey, to get rid of a 4th power, I could 4th root, right? Take the 4th root of both sides. But don't forget plus or minus, because whenever, just like when you square root both sides, right? If you take an even root of both sides, any square root, 4th root, 6th root, 8th root, any even root, you need to throw in the plus or minus, because also negative 3 to the 4th power would also give you positive 81. So when you're taking the even root of both sides of equations, don't forget to throw in the plus or minus. So it's going to be x is plus or minus 3, positive 3 and negative 3, 2 solutions. All righty. So we're just plugging away. Now, all of this was stuff that you had already, I had showed you videos on. I'm hoping you guys already kind of have a good understanding of this, but if not, I hope this video helps. Okay, let's try this one. Log base 1/16 of x equals -1/2. Is it possible to have a fraction base? Yes, it is possible to have a fraction base. You cannot have a negative number as a base, and you cannot have 1 as a base. It doesn't work because 1 to any power is just 1. So 1 as a base does not work for logarithms. Negative numbers do not work as bases, but you can have positive numbers that are any positive number other than 1. So fractions are good, or any other positive number, integers, all those kind of numbers. Positive numbers are allowable bases. Notice sometimes the exponent turns out to be negative. This is always positive. Also, this is called the argument of the logarithm. It is also always positive. This can never be negative or 0. This is always positive. This is always positive. Sometimes this can be negative though, like in this case. So let's see. I've got an idea. I'm getting the hang of this. I think I'm going to try converting. Okay, so what I take my base, 1/16 raised to this power, -1/2. Oh my gosh, x just popped right out. Son of a gun. I didn't even try. Look at that. I'm trying to solve. I accidentally solved for x. Oh my gosh, by just converting. However, I got to simplify this. Well, look at this. 1/16, I could call that 1/4 squared, or I could call it 1/2 to the 4th. Let's just call it 1/4 squared right now, okay? 1/4 squared to the -1/2 power equals x. Well, whenever you have a base to a power in the denominator, remember, you have an exponent in the denominator, I can move it up to the numerator if I make it negative. That's 4 to the -2. 1/4 to the 2 is 4 to the -2 power. You just move it to the other place, and it becomes negative to the -1/2 equals x. Now, a base to a power is multiply the powers. So you get 4 to the first power is x, which means that x equals 4. Wait a minute. Wait a minute. What am I saying? Am I saying that Brett Favre could have put that on the back of his jersey? Yes, that is what I'm saying. Sons of a gun. Much better than a 4. Right? Okay, anyways, whatever. Okay. Ooh, scary. Don't freak out. It's all right. It's all right. We'll do this one. It looks kind of fun, actually. Okay. Let's see. Log base 5 of cube root 1/25 is what? What does that equal? I don't know. Let's give it a name. I don't know. What do you want to call it? Let's say, x maybe? Okay, x. Now, this says 5 to what power gives me that? Well, guess what? I don't know off the top of my head exactly what that is, but, oh shoot, so what am I gonna do? You know what? I'm somewhat in doubt as to what I should do right now. I wonder if I'm in doubt, what do you think I should shout? Eat dirt? No. Convert, or no, I'd rather convert. That's what I'm gonna do, convert. So that's what we're gonna do, convert. This base to this power equals this crazy thing. Oh my gosh. Let's zoom in on what this thing is. That's 5 to the x equals cube root 1/5 squared. All I did is call 25 5 squared, okay? But then that becomes 5 to the x is cube root of 5 to the -2. I just made 1/5 squared into 5 to the -2 power. And if you remember, how do roots and exponents work in fractional exponents? They go like this, 5 to the power divided by root. So 5 to the -2/3 power. Look, 5 to this power is the same as 5 to this power. So now you can throw away the bases. X is negative 2/3. Guess what? We called it X. So when we find X, we found our answer. There it is. So the answer is negative 2/3. Son of a gun. Can you believe it? All right. That is great. All right. Let's see. Now, this may look a little tricky. There is a couple of these on the homework as well. It's not that bad. What we're going to do, as long as you think about what does the question mean and what is it actually asking. Okay, so here it is. It says log base 5 of 100 lies between the consecutive integers what and what, okay? Log base 5 of 100. Now, first thing I want to point out is log base 5 of 100 is not a nice number, not a pretty number. If you say, what's log base 5 of 25, it would be 2, because 5 to the second power would give you 25. But 5 to no particular power that I'm familiar with will give me 100, right? So the question is this is the question, 5 to what power gives you 100, okay? It's gonna be an ugly number, I'll tell you that right now. It's not gonna be a pretty number, and I don't know it off the top of my head. I'm gonna show you how you figure it out though. Let's look at the powers of 5. Okay, 5 to the first power is 5. 5 to the second power is 25. 5 to the third power is 125, and so on. Now, here's the deal. So 5 to what power is gonna be 100? Well, notice where 100 is. It's between 25 and 125, right? So 5 to the second power is too small. 5 to the third power is too big. So that means the power that you have to raise 5 to get 100 for an answer is going to be somewhere between the second power and the third power. So it's between the consecutive integers 2 and 3, right? And sure enough, if you do that on a calculator, which we'll show you how to do that later, if you do that on a calculator, you're going to find out that if you do log base 5 of 100, it's going to tell you that it's 2 point something, 2 point blah, 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 whatever. And that will be it. And notice 100 is closer to 125 than it is to 25. So actually the decimal number will be closer to 3 than it is to 2. It'll be bigger than 2.5. Okay, it'll be 2 point something. I don't know what it is, but it will be bigger than 2.5 because this guy's closer to this. So that is the power that you'd have to raise 5 to get 100. Okay, let's do one more like that. Similar problem. Okay, log base 3 of 70. Okay, same idea. 3 to no pretty power is going to give you 70. Okay, it's going to be kind of ugly. So let's see. Let's look at powers of 3 and see what happens. Okay, so we've got 3 to the first power is 3. 3 to the second power is 9. 3 to the third is 27. 3 to the fourth is 81, and so on and so on. Now, notice 70 is between 27 and 81, right? 70 is right in there. And it's closer to 81 than it is to 27. So that means this answer is going to be somewhere between 3 and 4, and it's going to be closer to 4. It's going to be 3 point something bigger than 3.5. It's going to be closer to 4. Like, I don't know, 3.8 something or something like it. 3.8 something or 3.9 something. That's what it would be. I don't know. I haven't figured it out. And that's not what the question's asking. The question says it's between which consecutive integers. So it's between the consecutive integers 3 and 4. That's how that works. Okay. Now, this one, okay? This is kind of interesting because if you look at it, you say it kind of looks like it's in logarithmic form, but not exactly, but it is in logarithmic form. I'll show you why. All right, now, what happens here? Well, notice, it's log base 8 of blah. It's so what that this happens to have a log in it, right? equals 0. So look, log base 8 of something, blah, equals 0, right? So don't worry that this says that, let's just call it blah, okay? So log base 8 of blah equals 0. So let's convert. That would be 8, this base, to this power equals blah, which is this guy. It just so happens to be log base 5 of x. I just did converting, right? Converting this base to this power equals this thing. Now 8 to the 0 is 1. Anything to the 0 is 1. I like to write my logs over here, so I'm going to write it like this. Log base 5 of x equals 1. I just turned 8 to the 0 into 1. Now, son of a gun, it popped right back into logarithmic form. So what am I going to do? Pop it right back into exponential form. This base to this power equals this. 5 to the 1 equals x. Oh my gosh, x equals 5. Cha-ching, there you go. Right.
Can I say?
What?
I was just gonna say that log of any number, any log 1 of any base is always 0. So that's something that's important for them to keep in mind.
Right, true.
Yeah.
And what's one of the most important things we learned today? This song right here. Because when in doubt, what do you shout? Convert or eat dirt. Mostly convert, okay? That's the idea. Remember that. If you get stuck, try converting. That's usually the right thing to do. It's not the right thing to do 100% of the time, but it's the right thing to do probably 80% of the time. So give it a shot. If you get stuck, that's the best advice I could possibly give you. So anyways, you guys have homework number 38 that I've already assigned. There it is. It's up on, I sent you an email with it. It's up on the website, all of that stuff. It should already be turned in by now. But if not, if you're having trouble with it and this helps you, more power to you. I also uploaded the answer key to this, and I went in excruciating detail explaining out. I didn't just work out the problems. I actually wrote down certain, like give it a name, call it X, and stuff like that. I wrote out some notes, so it looks long because I think it took 4 or 5 pages for me to write out all of that homework assignment. But you can look it out. I have the problems all worked out in detail. So there you go. Have fun.